just some more examples on integration, some different types of questions that you can get. First one, find the value of k if the integral between k and 1 of x dx is 4. So what do I do? What do you think I should do? Let's go. The integral of between k and 1 of x dx is, what do? Don't you go x squared on 2 between the values of k and 1? Well, that equals 4. So then I do my substitution. Okay. So what do I get if I substitute? I get k squared on 2 minus 1 squared on 2, which is a half, is 4. Now what should I do? Multiply through by 2. So k squared minus 1 equals 8. K squared is 9. So therefore k is plus or minus the square root of 9, which is plus or minus 3. And the reason it's going to work with the minus 3, negative 3, is because you're doing negative 3 squared. Okay, so that's how you do a question like that. What do you try the next one now? So same thing. Find the value of k if the integral, very similar. And because it's a fourth, you've got to take up to the power of 4, it's got to be plus or minus. If it was a cubed, you would just do the cubed root and get whatever you get. But when it's an even, because you can multiply negatives 4 times and still get a positive. Okay, the next question is the following. Now this is following on sort of from what we were doing yesterday. So here we go. Another example, differentiate. Oops. So differentiate the following. The square root of x squared plus 1 with respect to x. Remember, don't get confused between differentiating and integrate. Hence, evaluate the integral between 1 and 0 of x over the square root of x squared plus 1 dx. So just follow the steps. So if you have to differentiate that, you can write d by dx of that, or you can say let y equal the square root of x squared plus 1. And what would you do next before you differentiate it? Yeah, you can't differentiate it like that. That's what y is. So therefore dy dx, or y dash, or whatever you want to call it. Or you could have written let function of x equal that. That's probably better, but it doesn't matter. Whatever you like. What do you get when you differentiate? So when we differentiate, we get a half x squared plus 1 to the power of negative a half. What else do I do? Times 2x, no plus c for differentiating, which is x times that, which is x over the square root of x squared plus 1. Are you okay with that? So that means if you differentiate y, dy dx is this. Therefore, if you integrate that, you get that. See, because we don't know how to integrate this. So that's why they present the question this way. If you differentiate that, you get this. Remember, integration is the reverse process of differentiation. So if you differentiate that, you get this. So if you integrate this, you get that. Therefore, the integral between 1 and 0 of that is, well, I know how to integrate that. I just get the square root of x squared plus 1. We good? Between the values of 1 and 0. Do you get it? Do you see why they're posing the question the way they do? Which is the square root of 1 plus 1, which is 2, minus the square root of 0 plus 1 is 1. Now that's an exact answer. You cannot simplify that. Okay? And you can just practice one on your own now. Oops. We'll learn how to integrate this later. But, or maybe not, I can't remember. But the thing is, we so far only know how to integrate x to the power of n and ax plus b to the power of n. That's all we know how to integrate. So if they ask you something that's a product or something that's a quotient like this, there's no quotient rule for integration. So to integrate this, you're going to have to know what, you have to be able to differentiate something first. All right? Have a go at this one. Now, they won't always be straightforward like that. Sometimes there'll be a factor and we have to compensate for the factor. Now, we saw that when I introduced integrating ax plus b to the power of n, but we are going to come across some more of those in a minute. Another name for integrating is anti-differentiation. It's the reverse process. So integration is actually anti-differentiation. It's the reverse. It takes you back to where you came from. All right? Do you get that? With this one, when I ask you to differentiate this, you can write it 3 different ways. You could do it like this. You could say let y be that, or you could say the function of x is that, therefore f dashed x is that. You tell me what you want me to write. It's just that, how else am I going to say that this is the function and this is the derivative if I don't define it? So either I can go let y be that, or I can say, well, that's a function in x. Let function of x be that. I can't just write that and write the derivative on the next row and not say that that's the original function and that's the derivative, because you'll lose a mark. So you've either got to say y equals that, or f of x equals that, or you could even write d by dx of that. So you could do it 3 ways. You could write y equals that, function of x is that, or I could write d by dx of that is. Now, so I can now write that's my original function, my derivative function is. What do I use? Quotient rule. V u dash minus u v dash over v squared. V is x squared minus 1. U dash is, so u is x squared plus 1. U dash is 2x. V is x squared minus 1. V dash is 2x. So v times, now u dash is 2x minus u is x squared plus 1. V dash is 2x over x squared minus 1 squared. So, you know what? You might want to expand. I would expand. Do you get what I'm doing, girls? I'm differentiating. So I've got 2x cubed minus 2x. What else have I got? Minus 2x cubed minus plus. Yeah, same. Oh, no, good. Minus 2x. Excellent. Yep. And that's what I want to get. So what have we got? We've got negative 4x over x squared minus 1 squared. I'm glad we got that. Now, this is not the same as question 2. This is not the same as question 2. This is a little bit trickier. So, watching, if you differentiate x squared plus 1 over x squared minus 1, you get this. So if you integrate this, you get that. But the problem is I don't want to integrate this. I want to integrate with just a 4, with just an x on top. So I'm going to write down on the next page, right, what I've got. So I know that the integral, this is what I got from part 1, of negative 4x over x squared minus 1 squared dx means I'm just integrating with respect to x, is this. You okay with that? So what I did in part 1 is, in part 1, I know that if I differentiate this, I get that. Yeah? So therefore, I know if I integrate this, I get that. So I've just written that up here. From part 1, I know that if I integrate this, I get that. We good? But I don't want to integrate this. My question is to evaluate, not that, but to evaluate, why is it a K? Oh yeah, all right, K0 x over this x squared minus 1 squared dx. Now, I don't know how to integrate this, but I know how to integrate that. So I'm going to write that out. We touched on this yesterday. How am I going to make this look like that? Take the 4 out. Where do I put it? On the denominator or the numerator? I'm trying to integrate this, but I only know how to integrate that. So what I'm going to do, I need to write down what I can integrate, but I'm going to have to balance that to make it look like this. Don't I want to get rid of the 4 off the numerator? So I stick a 4 on the denominator. But isn't that negative? So I've got to put a negative. Because 4 over 4 is 1. I need 1x. At the moment, I've got 4x, so I've got to divide it by 4. I want that and this to be equal. I want to integrate this, but I only know how to integrate that. What is out of place? It's that. Now, negative 4 over negative 4 is 1. So if I just put a negative 4, it doesn't, I need to get rid of the negative. So a negative times a negative will now make it positive. And a 4 divided by 4 cancels. Do you get it? Do you see? I've got 4 over 4 cancels. A negative times a negative is a positive. So that and this are now the same. Do you see that? So, therefore, my result is 1/4 times the integral of this. I know the integral of this is that. Because when I differentiated this in part 1, I got that. So if I integrate that answer, I go back to the original function. So I've got 1/4 x squared plus 1 over x squared minus 1, and I'm substituting between the values of k and 0. I don't need plus c because it's a definite integral. So I've got negative 1/4 k squared plus 1 over k squared minus 1. Oh, I'm not finished. Minus. Girls, do you get what I've just done? Sorry, I don't think I recorded that. So remember, if you differentiate this, you get that. So if you integrate this, you get that. So we're trying to integrate this, but we only know how to integrate with the negative 4x on the numerator. You've got to balance out that 4. A 4 on the numerator will balance out with a 4 on the denominator, and then they will go when you multiply them. And a negative times another negative gives me a positive. So now I just integrate that. We know that's x squared plus 1 over x squared minus 1. And then I do my substitutions for k and 0, and we get this. It'd be a really good idea to make a common denominator here, because that's not simplified form. Okay, and then the k squareds, you can add them and the 1's cancel. You can do some simplifying here with the 2 and the 4. And then you can write it like that, or you just multiply the negative 1 by the numerator and 2 times the denominator. You can expand it if you want. You don't have to. Negative k squared over 2k squared minus 2. Either answer's fine.